What's up, legends? Welcome back to another video of indexing, and we've already explained blockchain indexing, what it is, why you need it, and we've actually quick started and we're already indexing this eigenlayer strategy manager contract, where if you have a look over here, eigenlayer, and you go through the contracts, the strategy manager is actually the main entry point where people are depositing funds in and out of eigenlayer. So to show you where we've got so far, this was all generated really easily through the quick start, so go check that out if you haven't already. But all we need to do is run this pnpm envio dev, and what's going to happen is in really no time we are going to scan 14 million blocks, find there's no events there, keep scanning, and essentially index all 150,000 deposit events. Now what we talked about in this next video was going ahead and doing indexing of users and actually getting an understanding of, okay, so there's been 150,000 deposits into this eigenlayer strategy contract, but how many of that is from unique addresses, and can we find a way to easily maybe find how many deposits per user there is? You could have a leaderboard who's done the most deposits or something like that. There's lots of different things you could do. So as you can see, it takes less than a minute to scan over 19 million blocks and index all 145,000 events. And just to show you what that looks like currently, we can see we have very nicely all the deposits. Great. We have an API where we can get, previously we looked at making this call to get the top 10 biggest deposits, and now we're going to go on. I'm going to stop this. I'm going to delete the indexer or clear the database, and we're going to actually do, as I said, this event part. So how do we do it now for users? So we're going to be adding very gradually to this. So the first thing I'm going to go do is define this new type of data, and it's going to be a user that we want to save. And very nicely, I'm getting some suggestions, I guess, from my IDE. I'll remove those two fields. We're going to have an ID over there, which is a unique identifier per user, and I think we are just going to use the user's address for that. And then we are going to create a field called number of deposits, and that will be of a type big int. And just like that, we have our new type over here. And now once we've adjusted the schema.graphql, we're going to have to run this command pnpm envio codegen. And what's that doing is it's creating the requisite types for us based on this new schema. So now when we go over to our event handler, there will be another entity available because we want to use types. So if we have user, you can see there's now this user entity that's available, and you can see its type. It's got an ID of string and a number of deposits, which is a big int. And we can start doing stuff with this user. All right, so let's go ahead and start doing that and look at maybe initially what some very naive implementation would be. Again, I'm just going to accept this because it's going to save me some typing. It looks quite nice. But you can see we have a user entity over here, and what we're doing is we are saying, okay, it's going to have two parameters, an ID, and we said the ID should be .params, who is the depositor, toString, right? Okay, so that's one parameter for the user. Just like that, this is obviously saying what type user entity should be of. It's of this type entity, and that's why it's complaining, because it says, hey, you've imported user entity, it needs an ID and a number of deposits, but you've only given it an ID. So now we would give a number of deposits, the second parameter it would need, and let's just say 1n. This is just a little shorthand for big int, no notation, because it's a big int. And then what we would do is we would set this in the database. So we use this context.user, which is the entity name, .set, and this user entity that we've just created, right? So very nicely, just like that, that's the basic start. But what that's going to do, right, is if one user deposits 40 times, it's just going to recreate them and keep setting their number of deposits at 1. So this isn't quite right yet. We want to change some logic. What we first want to actually do is we want to load a user if it exists, and that's where the loader comes in. Again, this is something that's really mapped out for efficiency, making your indexer a lot faster. And how we would do this in the loader is as follows. So ignore that long auto-suggested code. That's not what we're going to do at all. We are actually going to, in the loader, hit context dot user dot load. There we go, exactly. Again, we're going to access the event parameters and look at the depositor, and we are going to try load a user at this address, right? So this in our loader is just saying this is what we want to load, and this is again really efficient for various reasons, but we won't go into it. It's just a bit of code. If you don't add this, things will still work. There'll just be some warnings and it will be slower than it could be. So don't worry too much about the loader, but for every event we have a loader and a handler, and now you can see for the first time that's how we use the loader. Now what we want to do is we want to access that user if it exists. So we might say something like let our user, and again I'm just going to accept this and change the name. Let's say this current user is the name, and you'll see we use context.user.get, and again we're loading it with this string over here. And if this object exists, that means we already have a user, and if it doesn't, it means we'll need to create a user. So there's a couple ways we can do it, but I'm just going to do it in a expressive way. Again, this I'm going to accept this, although this is not what we're going to do because it's a read-only property. You can't use this notation. It's not as nice. So what we're going to do, if I say empty this if and else, is if a user does exist, our current user over here, then what we're going to do is we are going to say const existing user entity, and in this existing user entity we are going to ... use the spread operator and load in all the parameters of the current user already, right? So that's something that's really nice, and I'm going to leave this else statement for now. We'll come back to it. So this spread operator just says all these fields that already exist for the current user put in, and which field am I going to override. Again, that's been helpfully auto-filled for me. The number of deposits, I'm going to take this current user entity and I'm going to add 1 to the number of deposits, and I'm going to set this existing using entity. And otherwise, what I'm going to do is I'm going to create a new user entity and I'm going to set it. So very simply what we've done is we are now, whenever there's a deposit, we are doing exactly that. We're checking if the user already exists, and if they are, we're just incrementing the number of deposits. Otherwise, we are creating a brand new user, and in both cases saving it to the database. Cool. Maybe not the cleanest looking, but just a simple way, or rather write it in a more expressive way to understand the logic of what's going behind it right now. So now if we are to run pnpm envio dev, what's going to happen is we are going to see this in action. So again, things are going to index. which will be nice. And we're going to do some queries to see related to users what that looks like. So over here in the database, we'll see there are now users over here with various numbers of deposits. And what that means is we could make a query. If we scroll here to user, we could say, again, give us 10 users and order them by the number of deposits descending. We want to see as the most deposits, and let's give the ID and number of deposits. And if we scroll past that first result, here we go. The user coming up first is this user who has 147 deposits. So what we've been able to do is index this entire eigenlayer strategy manager contract and very quickly figure out through this kind of query who's the user who's made the most deposits. Maybe you would want to express and have a leaderboard, ether scan. Let's have a gander over here, and yeah, this is the address that's done all of those eigenlayer strategy deposits. They've been doing the most. Why have they been doing the most? I don't know. They've been depositing a lot every single day. Good for them. But yeah, that's an easy way to see it, which is really nice and cool. As you can see, it's already synced, which is lovely. And that is that. Let's leave it just there for now. So what we've done is we've now created more entities. We've written custom logic that saves users. And yeah, next time we'll focus on extending this indexer further and adding some more nice functionality. Cool. Cheers, everyone.